Good morning, Hawks. We're going to do a preview of the quizzes that we have today. Yesterday we did the practice quiz, Cut the Line, so that's the actual quiz for today. Let's go ahead and do that one first, make sure we're comfortable with it. So I have to do it, note here, I have to do it by 6 p.m. today, and we have 30 minutes to get it done. Back to the, whoops, that's not what I wanted. Daily quizzes, Cut the Line. Summary of your previous attempts, really? Oh, it's telling me I've already taken one. Okay. So we'll go ahead and take that one. Start a new preview. Thank you. Start attempt. Okay. So consider a line segment going from 5,8 to 16,8. Where would you cut the line segment so that the segment touching 5,8 is exactly 2 times bigger than the other line segment, the one touching 16,8? Note the new point is at x, 8. Oh yeah, so the y value never changed. So we're going from 5 to 16, and we want the part of the line that's touching the 5 to be 2 times bigger than the part of the line touching 16. Okay, so we have, right, so we have, oh, sorry, my writing tablet's tilted. Okay, that doesn't matter that much. Oh, you know what, screw it, let's start over again. Okay, so we have our line segment, and we're trying to cut it so that this is exactly 2 times bigger than this. This is at 5. This is at 16. Let's actually call this A and this 2A. You'll notice the length of this line from 5 to 16, that's 11. But you'll also notice that the length of this line is 3A. So we know 3A equals 11. But that means that A must be 3, whoops. Can't just erase it like I usually can. A must be 3 2/3, or 3.6666666 going on forever. We'll just round it off at 3.67. So that's what A must be. That's this distance from here to here. That distance is 3.67. Well, this is 16. 16 minus 3 would be 13. Minus another 0.67, that would put me at 12.33. Whoops. Right? Okay. .33. Finish attempt. See how bad we did. Submit all and finish, submit all and finish, and we got that correct. So, quick reminder what I did. I figured out where I was starting, right? Where I was starting, I started right here at 5. Where I was going to 16. That distance was 11. I needed to cut a new point, and this section of these 2 new lines that I just made needed to be 2A. It needed to be exactly twice as big as this part. Well, 2A plus A is 3A, so my whole line needs to be 3A, which is why we set 3A equal to, oh, whoops. Sorry. That's why we set 3a equal to 11. And then solving for a, right, just divide both sides by 3. 3a divided by 3 is just going to be a. 11 divided by 3, well, 9 divided by 3 is 3, and we still have 2/3 left over. That's where this 0.67 is coming from. That's the length of this small line. Well, 16, right? 16 minus 3.67, right? 0, 0. Well, we can't do 0 minus 7, so change this to a 5, change this to a 9, 10, right? How we do subtraction by hand. 9 minus 6 is 3, 5 minus 3 is 2, and we get 12.33. Okay, so that's where my answer is coming from. Hopefully that made a lot of sense. Let's go ahead and try the other quiz as well while we're at it. This is the practice quiz for today. It's area of a regular polygon. Now you remember we did the Pentagon, the actual building, the Pentagon. Find the area of a regular polygon that has 6 sides and each side is 10.2 units long. Note, a regular polygon is a polygon with all equal sides and all interior angles are the same. What is the answer? Okay. Okay, so we have a 6-sided shape. We know all these sides are the same length, and specifically they're 10.2. This one's also 10.2. This one's also 10.2, and so on. And all of these angles, right, this angle and this angle, whatever it is, these angles are the same. All of them are the same. Now, one of the ways we figured out we could do this when we did this in class with the Pentagon, that's terrible, is we could cut the whole thing up. That's still terrible, but whatever. Like a pizza. Right? Now, you're going to notice the base of this triangle is 10.2. This got cut exactly in half, so this angle and this angle are equal. And more importantly, so is this angle and this angle. And the distance from here to here, right, this distance, is the same as this distance from here to here, right? That distance is the same. All these triangles are identical. So really, we're looking at this triangle, and then noting that we have 6 identical copies of it. So if we can find the area of one of these triangles, then we should be able to find the area of all 6 of them. Well, we know the base, but we do not know the height. We also don't know this angle. Now, this is a little trick we did in class. And I don't remember which of you remember this, but if we cut our shape up into triangles, right? 6 sides means I have 1, 2, 3, 4 triangles. Each of those triangles is 180. Notice the reason I'm getting exactly 4, even though there are 6 sides. Oh, I hate this line right here. Fill this line in a little bit more. Okay. So the reason I'm getting exactly 4 triangles is because this side right here and this side right here, this triangle and this triangle have 2 sides, but these ones only have 1 side. So the number of triangles you're going to get is always going to be the number of sides minus 2. So in this case, we got 4 triangles, right? If it had 80 sides, right, then we would just subtract 2 and we'd find out that we would get 78 triangles when we broke it up into triangles. Well, each of these triangles has 180 degrees, and there are 4 of them. So that means all of the angles of this hexagon must add up to 720. Well, if you look back here, right, we have 6 angles, right? So we have 720, and we're dividing that into 6 equal parts. So each of these angles right here is 120. This one's 120. This one's 120. They're all 120. Well, we cut them in half to make this guy. Fortunately, cutting 120 in half is not too crazy. These are all 60 degrees. And we're going to use that to find our height. Now notice I just cut my triangle, my isosceles triangle, in half. That makes this 5.1. This part from here to here. Okay. I'm going to erase just this 10.2. Get it out of my way for a little bit. Probably should have used a hardened eraser instead of a soft eraser. Make that a hard eraser button. But let's actually go back to our pencil. Oh, whoops. Okay, so we're back to our pencil. Notice we know the adjacent. We want to know the height, which in this case would be the opposite. So we want the opposite. We know the adjacent. Oh, okay, so we're going to use tangent. Right, and we know that the tangent of 60 degrees is going to give me the opposite, which is what I want to know, over the adjacent, which in this case is 5.1. Right? Multiplying both sides by 5.1. That cancels. So the opposite's just going to be equal to 5.1 times the tangent of 60. I don't know that off the top of my head, so I'm going to go ahead and do that in a calculator. 5.1 times 60 tangent equals 8.833. Let's actually keep this. Should we go one more? No, that's fine. 8.833. Okay? So we now know the height. Right? The height of this is 8.833. Now, let's actually look at the base of the whole thing again. So cross that out for a second. Remember, it's 10.2. Okay. Let's actually get rid of this right here. Oh, and it did not get rid of the soft eraser, just so it's not cluttering our page. And because we're not really using this at all, this is just to tell us that if you had an 80-sided polygon, you could break it up into 78 triangles. Not really useful for us at all right now. Okay. Okay, so this is 10.2. The height is 8.83. Well, so then we would just do base 10.2 times 8.833. Let's move our calculator so we can still see our numbers. Clear. We have 10.2 times 8.833. 0.33. All right, hit equals. That is the area of the rectangle with that base and height. We need to divide that by 2 because it's a triangle. So let's divide that by 2. So the area of this triangle right here is 45.04. All 6 of these triangles are identical. So I'm just going to multiply that by 6. Since all of these triangles are the exact same as this one, this is the area of my regular hexagon. So we're going to use 270.3 because I told you to use 4 digits whenever you write an answer. You can go more. Right? We can write the whole thing if we want to. It shouldn't make a difference. So let's come back here. Paste that in. I can't see my answer, so we'll leave it at 270.3. Make sure that's what we actually have. Yep, you can see it right there, 270.3. And we'll go ahead and finish attempt. Submit all and finish. Submit all and finish. Okay, and that was perfectly fine. The correct answer it was getting was 270.30 because it was rounding up. I don't know if you saw that on the calculator. Oh, okay. Because we didn't use the 8.33459111, our answer was a little bit lower. So if we had used this number instead, so let's actually copy that number. Control C. Clear. And enter that number in. And multiply that one by 10.2. Right, and then divide that by 2. And then multiply that by 6. And you see we would have gotten a slightly higher answer because we rounded to 8.833 in ours. And had we not rounded, we would have been the exact same answer as them. But we were close enough and we still got the same answer. Hopefully that was a good review of how to do these things. Please email me if you get stuck. Think back to how we did with this at the Pentagon. You can do this. And I will see you guys later.